In this simulation, I will be modeling a JK flip-flop with an asynchronous set. So our inputs here are going to be JK, set, and clock, and our outputs are going to be Q and Qbar. The purpose of our JK flip-flop is with the asynchronous set. When set is 1, then Q and Qbar act as a set function. So Q is set to 1 and Qbar is set to 0, and that's regardless of what the clock says and what the inputs are. And so when the clock is on and when set is off, we have a J. If J and K are both 0, it works as a hold. So Q and Qbar remain whatever they were in their previous states. When the clock is on and set is off, and J and K are both equal to 1, it serves as a toggle. And so whatever Q and Qbar were previously, it is the opposite of that. In the complement. And if J is equal to 1 and K is equal to 0, it serves as a set. So Q will be equal to 1 and Qbar will be equal to 0. And vice versa, when K is equal to 1 and J is equal to 0, it will serve as a reset. Q will be 0 and Qbar will be 1. So we can go, and here is our test. And for this, we used a loop to basically iterate through all 16 possible input combinations using counter. And so let's go to our simulation. So here we can see, here is set, here's clock, here's J, and here's K. Here's Q and Qbar. And so let's go when they're defined. When set is equal to 0, we can then look at clock, and if the clock is on, which it is, we can see here it's on, then we look at the J and K. Now here, J is equal to 1 and K is equal to 0, which means that Q should serve as a set, which means Q should be equal to 1 and Qbar should be equal to 0, which we see here that it is. When the clock is off, we move over and we see that the clock has turned off and set is still off. So that means regardless of what J and K are, Q and Qbar should remain the same, which we can see here by the stagnant. Moving on, when K is on, when clock is on and J is now equal to 0 and K is equal to 1, it serves as a reset. And we can see here that Q is now 0 and Qbar is now 1. If we move over, we see that set is off, but the clock is off. So regardless of what J and K are, there's going to be a hold, which we see here. And Q and Qbar do not change. Now we see that set is equal to 0, so we can look at the clock. Clock is equal to 1, so we can now assess J and K. J and K are both equal to 1, which means there needs to be somewhat of a toggle, which we do see here. Previously, Q and Qbar were 0 and 1, and now they're 1 and 0, which means they experienced a toggle. Now that we see that set is 1, no matter what clock J or K is, Q and Qbar should be 1 and 0 because it serves as a set function, which we can see here. It doesn't change. Their outputs do not change. If we want to look at one more input combination, when the set is off, the clock is off, and J and K are both off, it doesn't matter because clock is off, so it should hold, which it does here. And if we go on, we notice that the clock is on and J and K are both at 0, which means that it is a hold, and which we see here. It stays at 1, 0 as far as the output for Q and Qbar. And that completes our simulation.